Welcome back to the S Factor. I'm your host, Chuck Schaser. I just want to thank you again for joining me today. And I know it's almost March Madness time, but we're not going there today. We're talking about Mars Madness. March Madness can be covered on other shows, sports shows. So we're all about science, so of course it's going to be a Mars Madness. Now, how many people saw Mission to Mars? I think that came out in 1998. I'm going to say I had Gary Sinise. I'm trying to remember the other actors. Now, at the time, we saw a face on Mars, right? What we perceived to be a face, a human face. Now, of course, that just made people go wild. Their imaginations ran wild with that. What in the world is that? That is definitely proof that there are people, there was an ancient civilization on Mars, because much like our ancients, they created things that could be seen by from an aerial view, right? They did that to appease their gods, right? So when people saw these images in the late 90s, they went wild. Oh my gosh, there's people on Mars. Now, of course, since then, with the technological advances with our camera systems, we actually can see close up what that face is. Our brains will put together a photo. If you don't have all the pieces, you have some things that are missing. And there's some evolutionary ties to this. So they believe that it's our way, it's like a survival mechanism. You're looking around, that looks like it may be a tiger. Oh my gosh, So just to be on the safe side, I'm going to assume that's a predator. I'm going to leave. Okay? So much in that respect, that makes sense to me. So that's kind of what's happening with the face on Mars. We didn't have a clear enough view of what that actually was. Now we do. So anyway, in 1998 or 99, I can't remember which, when the Mission to Mars film came out, that was one of the main features of that story. I'm not going to spoil anything for you, but if you haven't seen it, it's a great movie, and it kind of shows you why you need to wear a spacesuit. It kind of lets you know why it's so dangerous, that mission's so dangerous. But I believe it's a mission that we're definitely going to take. And if nothing crazy happens that wipes us out technologically or wipes us out, I think we will make it there eventually. We definitely have our goals set on going to Mars. But again, I want to ask you, would you go if it was a one-way trip? 856-696-0092. Now, what is Mars? Red planet Mars, named for the Roman god of war. Whoa. Easy. It has long been an omen in the night sky. Of course, you can see Mars with the naked eye if you know where to look. And in its own way, the planet's rusty red surface tells a story of destruction. Billions of years ago, the fourth planet from the sun could have been mistaken for Earth's smaller twin. With liquid water on its surface and maybe even life. Think about that. At one point, Mars, we know water was there. You can see the effects of water on the terrain. It could have been very similar to Earth, which is exciting to think. Now, however, the world is a cold, barren desert with few signs of liquid water. But after decades of study, using orbiters, landers, and rovers, scientists have revealed Mars as a dynamic, windblown landscape that could just maybe harbor microbial life beneath its rusty surface even today. Now, it has a longer year and shifting seasons, has a radius of 2,106 miles, and it is the seventh largest planet in our solar system, about half the diameter of Earth. Its gravity is 37.5% of Earth's. Now, Mars rotates on its axis every 24.6 Earth hours, defining the length of a Martian day, which is called a sol, short for solar day. Mars' axis of rotation is tilted 25.2 degrees relative to the plane of the planet's orbit around the sun, which helps give Mars seasons similar to those on Earth, whichever hemisphere is tilted closer to the sun experiences spring and summer, while the hemisphere tilted away gets fall and winter. At two specific moments each year, called the equinoxes, both hemispheres receive equal illumination. That is really cool. That isn't something that we experience on Earth. One side is light, one side is dark. But for several reasons, seasons on Mars are different from those on Earth. For one, Mars is on average about 50% further from the Sun than Earth is, with an average orbital distance of 142 million miles. This means that it takes Mars longer to complete a single orbit, stretching its year and its lengths of its seasons. On Mars, a year lasts about 669.6 sols, or 687 Earth days. And an individual season can last up to 194 sols, or just over 199 Earth days. So look at that right there, the difference. We have 365 days. They have 687. Are you interested in working? So 365, 687? The angle of Mars' axis of rotation also changes much more often than Earth's, which has led to swings in the Martian climate on timescales of thousands to millions of years. In addition, Mars' orbit is less circular than Earth's, which means that its orbital velocity varies more over the course of a Martian year. This annual variation affects the timing of the red planet's solstices and equinoxes. On Mars, the northern hemisphere's spring and summer are longer than the fall and winter. There's another complicating factor. Mars has a far thinner atmosphere than Earth, which dramatically lessens how much heat the planet can trap near its surface. So, the surface temperature on Mars can reach as high as 70 degrees Fahrenheit and as low as negative 225 degrees Fahrenheit. Ooh, you think that... Can you imagine? That's like instant frost right there. So, as you can tell, obviously, not very hospitable without a spacesuit. But on average, its surface is negative 81 degrees Fahrenheit, a full 130 degrees colder than Earth's average temperature. Now, the primary driver of modern Martian geology is its atmosphere, which is mostly made of carbon dioxide, nitrogen, and argon. By Earth standards, the air is pretty thin. Air pressure atop Mount Everest is about 50 times higher than it is at the Martian surface. Look at that. Air pressure is about 50 times higher than it is at the Martian surface of Mount Everest. Wow. Despite the thin air, Martian breezes can gust up to 60 miles an hour, kicking up dust that fuels huge dust storms and massive fields of alien sand dunes. Now, how incredible is that? Once upon a time, though, wind and water flowed across the red planet. Robotic rovers have found clear evidence that billions of years ago, lakes and rivers of liquid water coursed across the planet's surface. This means that at some point in the distant past, Mars' atmosphere was significantly dense and retained enough heat for water to remain liquid on the planet's surface. Not so today. Ice abounds under the Martian surface and in its polar ice caps. There are no large bodies of liquid water on the surface there today. Again, so we know there has been water on the red planet. And they assume there's, ice. Same thing with the moon. Wherever we go, when Hawking said, you must get off Earth, you have to eventually spread out the species. We have to be a multi-planetary civilization. And, of course, we can be a worrying people sometimes, which is sad, but that's the reality of life. But he wasn't talking about because we're going to do ourselves in. He was worried about threats from the outside. Asteroid. You could even have gamma ray bursts. You could have a coronal mass ejection that takes out our grid if it has a direct impact with Earth. In 2012, I think we missed one by 2 weeks. So the Earth's position in space would have been hit directly if that coronal mass ejection from the sun was in that path 2 weeks before. So it's very, very, very important that we migrate to other planets. Now, would you go? That's my question to you. Here's another question. Would you go to the moon? I want to hear what you have to say about that. Would you go to the moon? I mean, you can make trips back. Not a big deal. It's not terribly far. And we kind of know what we're dealing with. We've been there when Neil Armstrong stepped foot on the moon. We know what's there. We've studied it enough. We haven't been there in a while. It was 72, which is hard to believe. But we know we're familiar with the moon. Mars. We know a lot about it. Listen, those rovers, I remember when they sent the first rover over. Oh, I rhymed. Rover over. It was so exciting. I mean, that was news everywhere. You know, and to think that we're able to engineer a rover and communicate with that rover from Earth. Now think about that. We've all had remote control cars, right? Growing up. A lot of us have, I should say. Now the big thing is the drone. Everybody's flying the drones around. It seems like if you shoot video for a living, you pretty much have to own one of those. Drones are everywhere. Now imagine that technology, but on Mars. So you have a delay. I mean, what these people do, what these scientists put together with exploring these other planets in the solar system, being able to communicate, and there's really no room for error. You know, the last rover that they dropped was very large. And I remember watching how they actually designed this and were ready to deploy it, and everything that went into them dropping it on the surface of Mars. It was astonishing. There was zero room for error. There was a parachute involved that had to be deployed at a certain time once it entered the atmosphere. And this thing is booking as far as it's traveling down. I mean, my goodness, one mistake and that rover would have been lost, destroyed. You know, and you're talking about millions and millions and millions of dollars and a lot of time and effort gone. Thank goodness that we have scientists that are able to calculate these things and make the most of it, and are really, when it came to the latest rover, incredibly accurate with their measurements and how they time things. Really incredible. Now, Mars also lacks an active plate tectonic system. Now that's interesting. The geologic engine that drives our active Earth, and is also missing a planetary magnetic field. The absence of this protective barrier makes it easy for the sun's high-energy particles to strip away the red planet's atmosphere, which may help explain why Mars' atmosphere is so thin now. But in the ancient past, up until about 4.12 to 4.14 billion years ago, Mars seems to have had an inner dynamo powering a planet-wide magnetic field. What shut down the Martian dynamo? Well, scientists are still trying to figure that out. Now, the highs and lows, like Earth and Venus, Mars has mountains, valleys, and volcanoes. But the red planets are far from the biggest and most dramatic. Olympus Mons, the solar system's largest volcano, towers some 16 miles above the Martian surface, making it 3 times taller than Everest. Think about all the mountain climbers that have climbed our great mountains on Earth. They got to the summit, they accomplished their goal safely, got down safely. Oh, wait a minute, you're telling me? Now we can go to Mars and mountain climb? What? And are you kidding me? Absolutely incredible. 3 times taller than Everest. And there's more of this. The geology it's incredible. I mean, there's canyons that make, we have the Grand Canyon. I don't know if anyone's ever been out there that's listening, but that's breathtaking. Now, if we start traveling around the solar system, we're going to see some things that just absolutely blow us away. We saw the moon surface. Yeah, there's some big craters there. When you talk about what's on Mars, 16 miles above the Martian surface, the solar system's largest volcano, that is amazing. Imagine that, 16 miles. Now, it's so wide, it's some 374 miles across. The The volcano's average slope is only slightly steeper than a wheelchair ramp. The peak is so massive, it curves with the surface of Mars. If you stood at the outer edge of Olympus Mons, its summit would lie beyond the horizon. Now, they think its core is most likely made of iron and nickel like Earth's, but probably contains more sulfur than ours. The best available estimates suggest that the core is about 2,120 miles across, give or take 370 miles. But we don't know the specifics. NASA's InSight lander aims to unravel the mysteries of Mars' interior by tracking how seismic waves move through the red planet. Mars' northern and southern hemisphere are wildly different from one another, to a degree unlike any other planet in the solar system. And that's something they're going to have to keep in mind when they explore how different that is. The planet's northern hemisphere consists mostly of low-lying plains, and the crust there can be just 19 miles thick. The highlands of the southern hemisphere, however, are studded with many extinct volcanoes, and the crust there can get up to 62 miles thick. Now, what happened? It's possible that the patterns of internal magnaflow caused the difference, but some scientists think it's the result of Mars suffering one or several major impacts. One recent model suggests Mars got its two faces because an object the size of Earth's moon slammed into Mars near its south pole. It's two faces. It's very possible. Both hemispheres do have one thing in common. They're covered in the planet's trademark dust, which gets its many shades of orange, red, and brown from iron rust. So, if you're listening and you hate rust, you might not want to go to the red planet. You're going to see a lot of it. Since the 1960s, humans have robotically explored Mars more than any other planet beyond Earth. Currently, 8 missions from the US, European Union, Russia, and India are actively orbiting Mars or roving across its surface. But getting safely to the red planet is no small feat. Of the 45 Mars missions launched since 1960, 26 had some component of fail to leave Earth, fall silent en route, miss orbit around Mars, burn up in the atmosphere, crash on the surface, or die prematurely. Now again, it's no easy task to get there. Ask you the question, would you go? We have a caller on the line. Welcome to the S Factor. I'm your host, Chuck Schaser. Welcome.
Thank you.
What's your name and where are you from?
My name is Jen, and I'm from Estill Manor.
Hello, Jen. Thanks for listening. Would you go to the red planet?
Sure.
You would?
Yes, absolutely. Why not?
Now, see, that's interesting because I think many people would hear that one-way trip disclaimer and they would probably think twice about it. But you're saying that you would take that gamble.
I would.
Wow. Now, what intrigues you about that trip? What makes you say, yes, I would do it? Is it exploring? Is it going somewhere that we haven't gone before as a species and making history? Or is it to get away from your significant other?
Well, let me think about that. No, I think, I don't know. I think just to go somewhere else and see what's out there. I mean, there's no way that we're the only planet that has people like us that live on it. You never know what's out there.
So you think once we get to Mars, we will be greeted or maybe see something that indicates there is intelligent life?
Yeah, I think we need to be one step closer to find alien life.
Well, they're talking about microbial, so that's probably a sure bet. But
E.T. might be on that planet.
What was that again?
I said E.T. might be on that planet.
Well, E.T., I'm going to assume, came from much further away.
Yeah.
Another galaxy altogether, perhaps. But would you visit Europa, which is an icy moon?
I would say no.
No?
I don't like the cold.
Well, did you hear how cold it gets on Mars? I mean, it's very frigid at points. Well, you'd go to Mars, though, so that's one for Mars.
I would.
That's good.
And I always enjoy hearing your voice on the radio.
Oh, wow, that makes me feel good. It's a pleasure to be on, and I want to thank you for listening, and thank you for calling the S Factor.
Thank you. Have a great day.
You too. Wow, what do you think about that? We have a caller that would go to Mars. And my question to you is, would you go? You can call me at Cruisin 92.1 WVLT at 856-696-0092. Again, that's 856-696-0092. Would you go on a one-way trip to Mars? That is the question I give you today. Now, again, that's a one-way trip. That means you're not going to see your friends. You're not going to see your family. You're off to Mars. You're going to make history. You're going to make history. You're going to see that rust color. You're going to see that wonderful landscape the rest of your life. It's very possible. But so there are going to be a collection of scientists. Now, I would gather that there are going to be a lot of people that are clamoring to go, but we're going to find out what you have to say. We have another caller on the line here. Welcome to the S Factor with your host, Chuck Schaser. Would you go to Mars?
Of course not. Come on, really. Let's look at some facts here of why we would even get involved in that, other than the ego pride of man and engineering such a product and wasting money like that.
Mm-hmm.
We know that the planet's desolate. There's nothing there, really. It's a planet that technology-wise you'd have to have an atmosphere man-made, okay?
Yes.
So why would I want to see money spent like that when in the Pacific Ocean there's plastic garbage running around the size of Texas and nobody's even given a thought about how to clean that up? So resources and contractors and all the hush-hush, because now NASA's just a front of all these other contractors, with their technology, which is wonderful, but I find it's ludicrous to go to a planet you can just step out in the desert any place in the world and you have the same thing. Don't you think it's ridiculous?
Well, it's funny you mention that because, they have those biodomes that they set up. They try to recreate what the conditions will be like. And like you're saying, many times they are in a desolate place like a desert to try that out.
But the fact is, what is the opportune? What is the basic thing that's going to benefit mankind other than just the ego that we did it and we're there? We did the moon thing.
Mm-hmm.
Supposedly there's parts of the moon that some of the astronauts saw that is unexplainable, and I'll leave it at that because a lot of it's, conjecture and alien possibilities.
Right.
Or the Soviets were already there. I mean, there's all kinds of BS. But the fact of the matter is, with all that money and that technology, wouldn't you think we'd be able to really clean up some really groovy things, make the oceans really more viable than what they are now?
Well, when you talk about like terraforming, as I think what you're mentioning before, when you talk about terraforming Mars to make it Earth-like, if we can do something that drastic to Mars, we can certainly clean up our mess on Earth. That's the way I look at it.
But the point is, what is? You tell me what the benefit's going to be for you if we go to Mars. If we spend all this money, because it's got to be an extraordinary amount of money and many years invested into this endeavor. What's the benefit for you personally or for me?
Well, I think the question isn't for me necessarily personally. You talk about the ego thing, and you're right. It's a huge ego boost to make a leap like that. Absolutely. And to be the first nation to do it, more so, So you have that factor. But for me, to be honest with you, I want to see us survive as a species, and of course we should clean up our planet, no doubt about that. When you think about what Professor Hawking said about spreading humanity across our solar system, really to just give us more of an opportunity of survival, a better chance of survival, long-term survival. What do you think about that?
Well, that's because we can't even be humane to each other because every scientific endeavor becomes a weaponized idea. Okay? You talk about drones. Look, I was in the service. I've seen what drones can do overseas.
Yes.
Okay?
Absolutely.
All right? It becomes weaponized. And to me, like the moon would become a weaponized port. The space station, God knows what really the endeavor is. We villainize the Russians, yet they help us, and we use their, for the last 15 years, we've been using their heavy boosters to get payloads up there.
We have.
And now we're going to Now we contract it with old Elon Musk, who's the Howard Hughes of the 21st century.
That's right.
The bottom line is it always gets weaponized. You know that.
Yeah.
So why can't we look at how Cousteau was operating and clean up the plant? Wouldn't it be magnificent to see species abundant that are dying in the ocean that
Absolutely.
that actually sustain other cultures and other countries for protein? It's dwindling, man.
Absolutely.
And the fact of the matter is, there's the trophy. If we could set out one endeavor before we go to the bigger ones in climate change, clean up that Texas-sized sewer, get it out of there, and then move on from there. But we won't. We won't. We won't, because we've got to weaponize everything. I mean, that's how I am. I mean, I love the space program. Believe me, I grew up in the 60s watching it, you know? And it was a beautiful thing, but to me...
It is a beautiful thing. Space
you know,
travel.
To me,
and
now it's too goofy now that they want to weaponize everything. And they keep it very secretive. That's why it's all contracted out, because that way the Freedom of Information Act doesn't follow those companies.
Yeah, unfortunately, when you talk about... I'm going to have to get going, Call. I want to thank you very much for the call. Great call. Thank you for listening. I'm going to have to get going here. We're running low on time.
Right,
but yeah, what the caller mentioned here is, unfortunately, a sad fact of our human, I guess you could say, instinctually. You know, and unfortunately, we have to deal with that moving forward when it comes to any kind of new technological advancement, right? But
yeah, I guess.
Yeah, that's the way it is. And listen, we can only be optimistic about it. There's no guarantees with any of this, right? There's no guarantee the mission would even work. There's no guarantee that their technological advances would help clean up the Earth maybe the way it needs to be. So really, we can only work hard, do our part individually, and move forward.
Yeah, I see your point, but I think it's an easier endeavor to clean up the planet by starting one step at a time, and something tangible like what's going on in the Pacific with everybody dumping plastics out and it's floating around. It's being eaten by species. It's creating a lot of havoc within a lot of species, a lot of fish, turtles, the whole thing that in the 70s was supposed to be cleaned up. Like, turtles were eating those six-pack plastic things floating around.
Listen, you know about the coral reef.
Again with that.
Yeah, the coral reef situation.
That's what I don't understand. We abandon things, and then we go on to these other things when we haven't really corrected the things that are happening here, and they're easy corrections. That's what I believe, and I just can't see wasting the money. Like I said, I'm repeating myself. I get it, but
it's okay.
You're a man of science.
Yes, sir.
I mean, and how much of technology have they kept from us because they weaponize it in the end?
Well, unfortunately,
in the end, it becomes a weapon.
Unfortunately, yeah. As long as we have that mindset, who's controlling the world, who's controlling technology, we're going to have to deal with that. Caller, I want to thank you for joining me today. And I want to thank all of you for joining me today.
I want to go there, man. There's no beach.
Hey, man, it was great talking to you. Thanks for the call. Thank you for listening. Do you love science? If so, subscribe below and never miss anything from the Science Animated YouTube channel.